doing CDC with Unity and Spark. So in this session, we will talk on Delta Lake, which is the framework open source by Databricks, and now it is part of Linux Foundation, where we'll talk about how you can have a transactional log at HDFS and Hadoop, which means that how you can have a ACID transaction can perform on top of HDFS and Hadoop. So I will brief you on that, and then we'll proceed further with the code time examples, right? So coming back to why there was a need of such thing, right? What is that which is not possible with Hadoop and Parquet? So mainly when you go with Hadoop, you will store the data in form of a couple of other formats like Parquet, Avro, then you can store data in format of ORC. Most of the HDFS data, as I said last time, that HDFS allows you to access the data in a form of sequential access, which means if you have a bigger file, let's say 5 GB of file, and if you want to access the specific record from that specific file, that is not allowed by HDFS as per the design of HDFS files, right? Now, if you have a Parquet file, you got 1000 records. Now, if you want to access specific records, which belongs to, let's say, employee ID 123, you won't be able to access that unless you scan entire file. Now, most of the HDFS file schema structure like Parquet are being columnar fashion. So every data is stored in columnar way. So it is faster to read specific column compared to read all the records. So that was a side effect and disadvantage of that. So that is what going on in data science and big data community, that how can we have something where can we do schema transaction logs and operate the data and delete the data. So in nature, the HDFS files are immutable. Parquet is immutable, which means that you cannot, once you write, you can't operate and delete the sum of the part of the files unless you can do two operations. One operation is append. So if you have 1000 records and would like to add 2 more records, you would be able to add those 2 records, and that operation is known as append operation. Now, other operation which you can do is overwrite operation, which means that you can completely remove the data which exists at the HDFS in the form of Parquet or any other format and rewrite the data to the HDFS location. Now, these 2 operations were very expensive operation because overwriting everything in, let's say, 10 GB of data, that is one of the cumbersome operation, right? And that causes so much of performance impact to your infrastructure, to your data, to your jobs and everything. And main reason behind these 2 was schema enforcement and schema evolution, right? So what is schema enforcement? Schema enforcement in layman terms for those people who are working with database system is that you have a source table and you have a target table, but the data type is different. Column names are different in terms of case sensitive and in-case sensitive, and the object type is different, and whether it can allow the null or no, that's different. Those kind of aspect of the schema for the table is known as schema enforcement, right? And so if schema structure is different and you write back to target, then what will happen? The target system will have a separate different schema structure, and that might fail your downstream application and the downstream jobs, right? And schema validation was very important, and which occurs at the right in Delta Lake. If schema is not compatible, then Delta Lake cancel the transaction, no data is written there. And as well as you need to raise exception saying that, oh, that it is not matching the type of data type that we wanted, right? Why schema enforcement is important? Again, that as you know, that if there is a downstream application which is qualified to read as a string and then you provide integer, then it might fail all other API that you have in Java or Scala or whatsoever it is, right? Now, also it is very important when you work with any other application like machine learning or BI dashboard, like if you have configured Tableau and you say, oh, this is a string, and then you pass integer, that will fail, right? Data analytics, visualization tools. If you have Node.js web service written on top of the tables that you have in MySQL, let's say, where you expose the microservice and consume the API through AngularJS or React.js, and that will also fail their systems, because you are giving different type of data type, right? To say that the float operation to calculate some other operation, and if you pass the string over there, it will fail, because it requires the float to type that, right? And Java Spring microservice is very much type safe. If you pass different data type, it will fail that exception error, right? So it's very important. This is also kind of data cleanliness that you prepare. Any production system requiring highly structured, strongly typed and semantic schemas, right, also requires schema enforcement, because it might fail at any time. In order to prepare their data for this final hurdle, many users deploy and employ the simple multi-hop architecture, where that is progressively adds structure to the tables. Now, it is also not good that if you say, oh, let us change the source schema structure, right? Now, if your schema is keep changing, right, it's not slowly dimension, it is kind of very heavy dimensional schema structure, which change anytime because of source system changing. How you can handle those systems, right? We will talk that in real scenario, what kind of use cases that we have, which tells you that how this kind of problems can come, right? Now, schema evaluation, when you write Spark dataframe.option overwrite schema, you can tell true. This tells like, oh, whatever schema my target has, can you please overwrite schema? Okay, it can overwrite. But this is not solving the real business. This solves the business problem, but this is not, this gives the performance penalty to us, right? This is not something which gives you highly, which writes for you highly efficient systems, right? With very minimal change that you want to do over there. No, this is not the one. What you have to do, that we'll talk, and why we are here to discuss on Delta Lake. That is what is key for us to understand that. Non-read compatible schema changes. Some of the schema changes are there which is not compatible to read for Spark API. How we can deal with that? Typically, when you overwrite, everything is overwrite. You don't have even other historical data once you overwrite that. The following type of schema changes: dropping the column, add new column, change the data type of column, and change the column name. Now, renaming column names differs by case. If you in SQL, RDBMS, if you say FOO, F capital, and F small, both are same. No one will question on that. But when you work with type safe programming language like Scala, Spark, Java, right? F capital and F small doesn't matter here, right? FOO, foo, capital and small has different understanding there, right? Coming back to Sam, these are the use cases why we need that. Once we understand that why we need that, that becomes very easier and quicker to implement some of the design and solutions that we have, right? Now, what are the options are available in open source ecosystem that can be used and that can help you to overcome this problem, right? Now, I hope everyone understand that. Let's say you have one big directory, okay, in that you store all the employee data in Axion employee data. Now that file is immutable, means once you write, you can't change it. So what option you have? Once HR says that, oh, the X person got released from this team or this company, what are the options you have? Either you will write again new file that you wrote, and then you will overwrite the same file with the existing file, right? Or it is very easy for HR, when you have new employee joining, then you just need to append one more record to that file. But when existing schema change, right, people leave the company, people resign, or people get fired, right, those records you need to change with that. Now, every time you prepare other file and overwrite the file, that takes time. Rather than what you do, that you need ability to write, to update and delete records from the existing file, right, which wasn't being allowed so far with HDFS in Parquet formats. So ecosystem wanted something, okay, which is kind of extraordinarily efficient program that do minimal computation which is possible, and gives you the efficient output for your system. So for that, in the in the open ecosystem, what we have is the schema is two systems: Apache Hudi and Delta Lake. Apache Hudi is open sourced by Uber open source team, and Delta Lake is open sourced by Databricks. Both can serve the similar purposes, right? And eventually, we don't care that which open source system we use, as far as we get couple of things being proved. One thing is our performance. Second thing is true ACID transaction HDFS. Means you read whatever you read and you update whatever you want to update, right? And third thing is what? The side effect and the performance penalty, if it goes something or not, right? So to give an example, I have simple query system with me. Let me see my screen. If you can see my screen, this is how fundamentally, this is what we really want, that if we create the database called create database demo. Yeah, let me increase the size. Last time people complained that we can't see proper font on your video. So create database demo, and then we use the demo, and then we create table called Hudi delta test. In that we have primary key, which is integer. We have name called Wacker 255. We have value, that's integer. And then we have two columns called updated underscore 8 and created underscore 8. Now this is timestamp, and default value is now, and on update also now. And you have create at is also now, means anytime you insert record, this column will get inserted the new timestamp, accordingly current timestamp. And when you update something, this will also create new current timestamp being updated. And then we are inserting 4 records, okay, one Apple, Samsung, Dell, Motorola, and the value with that. So how it looks in your system when you go back and look at the when you select star from the table, what you see is this, right? Now this gives you kind of essential information for you to know the what are the records being updated, what are the records being inserted, right? And if you have a downstream system where in the Parquet, let's say in HDFS, if you have 1000 records and then you would like to know that last record was inserted what time, then you go back to this table and say select everything where the create add is greater than my last insert date and timestamp that you have in HDFS. Similarly, you go back to update it and add the similar condition, and based on that, you would be able to only read the records which have been got newly inserted and newly updated, right? So this is kind of basic fundamental when I talk about how to only read incrementally and process data, only change data, right? Because we don't care that what was heartbeat of the engine 2 days before than what is right now, because this is what, I mean, as far as you don't have any other impact on your present system and the future system, you don't care about your past system, right? And then how it works. So that's the reason we only pull the records which have been changed as far as your current system is working properly and perfectly. So coming back to that, this is eventual requirement. Now how we can get it with performance optimization without performance penalty? For that system, you need to use some of the frameworks like Delta Lake, and that's one of that which we were talking about today. That what is Delta Lake and why we need that. And Delta Lake is the library. You can go to delta.io and then and learn more about that, and as well as you can download the library and use that. So Delta Lake sits on top of the Spark, right? It is natively supported with the Spark and Scala and Python and Java. You can connect with any data source with Delta Lake as far as Spark supports that. It is natively been supported for streaming applications and batch applications, right? You can ingest the data in a, let's say, bronze table. Bronze table means the as it is. You don't do much more refinement over there. Once you ingest your data here, you create one more copy of the data. You call it refined table. Means the only records you need for your aggregation and your analytics process. Once you have that, you do the aggregation on top of that, right? Because the business cares about the KPIs, okay, the key performance indicators, and those KPIs are valuable for business and salespeople and finance team to understand that what is happening in the business, right? Why we do analytics is because the business can get a 360 view of the enterprise and organization, that what is happening. And the raw data is all transaction data, which you ingest here, and then you do aggregation, and this becomes the gold data. Okay, this is the valuable for analytics and machine learning and for everything to take decision on top of this aggregation data, right? Your existing data lake, that can be anything. Your data storage can be HDFS, Azure Data Lake Storage, and Amazon S3 bucket, can be anything. You can just store data wherever you need, not eventually only need for HDFS. Can be on cloud, can be on premise, and can be on self-managed service. Now, this is all good, right? How it works and these things. Now, how you can integrate with your project and how you can consider this as a biggest use case, right? That's important to know for us. So consider this as one of the use case where you have data in MySQL, MongoDB, MS SQL Server, DBA, you have payroll data, you have inventory data. Now you want to fetch all the data in your Airflow, in your data lake. Now this is an end-to-end design where you connect this to your Spark read, and then you have Delta on S3 bucket, let's say, and this can be on Databricks, Amazon, EMR cluster, or Databricks, or on-prem, whatsoever you want to have that. Now this Airflow's role is here to schedule that, keep pulling the data from this source system. And unless this is not streaming system, this is frequent batch. If you have a streaming batch, then you don't care. You just keep pulling the data as far as changing and process data at S3 bucket in Delta Lake. And then you have semantic layer, where semantic layer means that you have to, you can have your aggregated and processed data warehouse wherever you want, and Snowflake can serve that purpose for you. And then once you have other schema there, that's called aggregated processed data, that you connect with your reporting layer called Tableau, Looker, and Qlik, or anything that you would like to use that over there. So this was eventual integration with your product system, that how you can integrate Delta Lake with that, and how it can play the essential role with other ecosystem tools like Airflow, Spark, and Snowflake, and those others, right? And what are the features it brings to you is time travel, means you can have data versioning, right? Even though, let's say, HR in the company can update that some person got released from this team, you can still have the data versioning, that what he was doing earlier, what he was working on earlier, all data still lies there, okay? So we have one fundamental thumb rule, that any data we insert, we never delete that. We change the flag and we process different event as an event system, but we never delete that, because all the data we have that help us to derive some conclusion, that how the people are behaving, how people are working, what kind of pattern is coming, and that is what is helpful to us, right, as a data engineering folks. You have updates and deletes, you have ACID transactions, means you can update and you can delete, which was not possible with our Spark earlier with Parquet. You get 100% compatible API with Spark, and you have chain data capture. You can only capture the data which is changed with the functions like version of and timestamp base, and it's fully open source system. It's driven by community over there. And before we proceed further with the code, let's understand what kind of problem it might cause if you don't have such systems established there. Data reliability changes with data lakes. Sometimes what happened, that failed production jobs leave data in corruption. Your Spark job is running and it got failed. So half data is written and half data is corrupted, and there's no use of data. So every time what you will do full load. lack of the quality enforcement creates data inconsistent and unusable data. If you have a job downstream that requires 5 columns and you have only 4 columns to be written at HDFS, then what will happen that downstream job won't be able to read 4 columns. That can be Spring microservice, that can be Node.js microservice, that can be anything, right? And lack of transactions makes it almost impossible to mix append and reads, batch and streaming, right? Unless you don't have transactions available, you cannot have 5 streaming jobs writing to one Parquet, right? Because you can't do that. That's limitation of existing system. Unless you put delta.io, you can't have that. So let me go back to some of the code that I have to show you that how these things works. And then we'll also front back to call Hudi and how Hudi performs some of the things once we're done with the Delta Lake. So same thing, the Scala project, you will have to import the only one library called delta io.delta and delta core. Once you have that, that's everything done. You don't have to do any other configuration, any other setting, just import one library in build.spt, and this is line number 10 will suffice your purpose here. Now I have got Scala project in that, and example 1 is the simple straightforward code which explain you that why you have this and how can we proceed further with this, right? So you can import called io.delta.tables._, which brings most of the all APIs for you that you need in the project. So I hope people can see my screen, right? The IntelliJ code or?
Yes, Chetan, we can see.
Thanks, yeah. Sometimes I just keep speaking and if I don't know whether people can see screen, yeah. And then what you can do is that you can create object example 1 and extend the app. App is in trait in Scala, which gives you all argument that you have to pass and those things. So you don't need to create main method once you extend the app. So how you can create the delta table, right? Well, this is called immutable data spark.range. I'm just creating 0 to 5 range data and then saying data.write format delta. Once you say format delta compared to format Parquet, this will just create the delta table for you, right? Now you can use this delta table in spark.sql to query in a SQL syntax as well as in Scala syntax. Now I'm reading this data called spark.read.format delta load tmp delta table, and then you can have a natively supported data frame object here which gives you the similar output that any other data frame gives you in Spark, right? How you can do overwrite. Similar to that, you can say overwrite here. In save mode, you can have overwrite here, and this will overwrite completely your delta table that you have. Now, this is fair enough. You can have full load return, you can have overreturn, right? How can you have conditional update without overwrite? This is the main use case. That's why we are here, to understand that what delta.io and delta lake offers to us, right? Now you can have delta table and you can say delta table.for path and mention the path name here, which is what created earlier. Now delta table.update, you have a condition that expression when id modulo 2 is equal to 0, at that time you want to set the id is equal to id plus 100, right? When existing id 5 to 10, right, you have, when it qualifies your condition called modulo is 2 is equal to 0, you want to update the id is whatever value it has plus 100, right? That's how you can define this. Now if you want to delete something, you can just say delta table.delete condition expression id modulo 2 is equal to 0. Now in this expression, once you define that, the delta table does delete for you. And if you want to upsert, means you want to merge the data. Upsert means what? If exist, then update, otherwise insert, right? So you create this data frame called 0 to 20 and data frame, and you set data table as all data, merge new data as new data, and then you provide the condition all data.id is equal to new data.id. When this get match the condition, you want to do update with the map id is equal to new data.id. But when it's not matched, you just say insert, and whatever data structure you provide here, it will just insert for you and execute. Now this what you can see here, which is done in one SQL DSL, this takes 7 steps when you work with Sparky and Spark, because first you will delete that, you will write back to other temporary folder, then you will do join and find out left outer join and find out newly added data, and also you have to compare with the hash and find out the similar data and been updated, and new data you have to do right outer join and find out those things, right? So you do 3 query, you do one more join, and you do overwrite. Those 7 steps are done in only one DSL here, right? You don't have to do anything else. That's all. And finally, you can do delta table.2df.so, and this will give you the finite vital information that you need for your data frame. And now this still persists historical data for you. And if you want to read older version of the data using time travel, this does support. You can just say spark.read.format delta option version of and then say 0. So you want to get a 0th version data from this path. Then you could say first version, second version, third version. As far as this update and delete is happening, you can just travel the time. Okay, you can go in history, you can go in past, and you can be in present, and you can go in future once you write the new data with that. So that's one API called option version of, and this gives you, if you are maintaining the version of your Spark jobs at any database, let's say you have other RDBMS table called MySQL or something like that, and you store your incremental version. Once you write, you say 0. Second time you write, you update to 2, 3, 4, 5, like that. And at the end, you semantically map the versions of your process data with your Spark, right? And then you can pass that value at the version of, which is hard-coded 0 here, right? And customizically only pull the data which is changed in the delta table, right? Now, this is one of the approach. I think last time also when we discussed with the CDC, we discussed there are a couple of things to read data: versioning, timestamp, and third thing is transaction logs. This delta.io supports everything for you, not single type, everything, 3 of that. The delta rate transaction logs guarantees exactly once processing by default, and you can thoroughly convert this to streaming based application also. Let's take an example: spark.readstream format and rate and load, and then you can say streaming data frame dot select this. You can write back to stream with only one keyword and function called write stream, and you can say format of delta. So stream can also contain delta format, right, for you. And then you can have a checkpoint location where you want to have checkpoint in case of any failure, where it can go back and recover the data. And this is your checkpoint location. And then you can say start. When you start, it just triggers that, right? You can also read from the streaming application, same format, and have start here, right? Now you can also have a timestamp based conditional formatting. Let me say the example with you. So if you see this one, data frame dot write dot format delta, you want to do overwrite, let's say, an option replace, only replace this records which qualifies this condition and which belongs to this range of the date greater than equal to 1st January 2017, and less than equal to 31st January 2017. C means you want to only replace the data which comes in January 2017 bucket, right? So you can just say second thing is replace where, and here you can provide the timestamp, and that can do the things for you. So this will only overwrite those records belong to this 1 month, not everything for you, right? Which was not possible in Parquet, let's say. So you can have that also handy. So any questions so far on Delta Lake or Delta.io or transaction logs on HDFS? I would like to answer that before proceeding further with the other system called Hudi, and how Hudi can help you to have transaction logs on HDFS.
So Chetan, Shubham here.
Hi, Subha.
So yeah, hi. So where did you add jar for the delta?
But yeah, so if you go to build.spt, here is where I add delta jar file. So when you do spt build assembly, this will produce the uber jar for you, similar to in Java you have pom.xml. When you do mv and clean build or package, at that time you provide this dependency, and this will just wrap to your uber jar which you prepare.
Okay, so in PySpark also we will do the same. Suppose I am running Spark on EC2, that is a single node cluster, and
Okay,
I want to run, I want to use this data lake concept. Where do I need to keep this jar?
I think you, as far as I know, when you run this PySpark, right,
Yes.
you get configuration utility for that, where in PySpark command, if you provide that, let me share that how you can do that. There are couple of ways to do that, but easiest way is that when you say PySpark, right?
Yeah. Yeah.
But I hope you will have. Let me use somewhere here. You can just say PySpark and say packages io.delta :delta core and the Scala version, and this is C
Right.
delta.
Right,
So
Chetan. So this will give interactive mode, right? Suppose I want to run my jobs, so I do not want interactive mode. I just want to, run my jobs in production or somewhere. So shall I keep this? Shall I
you
download this
can
package
download
and
this
install?
jar, put somewhere, and then when you refer that, as far as this question is very simple. That this will be downloading from internet, right? Let's say
Yes,
your
yes, and we
production
can keep
system
it.
doesn't have access to the internet. What you can do, so then you can download this jar file, right, from MV and repository. Once you download that and keep in HDFS, and then only give path to that, the same way you give hyphen files, right, or hyphen jars
Yes.
also, also suffice your
Yeah.
purpose of that.
Yeah. So where you are keeping this delta, you are keeping delta on S3, right?
In this example,
Yeah. So in this example, I think you are keeping it on
in this
S3, right?
example, I'm keeping on HDFS natively.
Okay, okay, HDFS. So suppose I have to, maintain a incremental load, history load I have. So
Correct, correct.
will that cause a storage issue? So will that be, increasing gradually that delta?
So good question. Good question. That how long this transaction history will be there. Whether first time I do full load, I process full load, and then how much storage it would be there. Right now, it really depends on how much data you get and every change that you have. Right. Um,
Okay.
so let's say every day you get 10 records, then it won't cause. But if you get more data every day, then you need to come up with a data cleansing strategy that that for your business, how past data is important, 1 month data is important, or how much data you want to keep, right? So if your business need as per your aggregation, then separate case. But if you don't need that thing, then you can clean the data. Now, Delta Lake, there's a method called vacuum. So vacuum will clean your data from Delta table. Let me show you example that how you can clean data and how you can pass, how you can create the strategy to clean the data, right?
Yeah. And Chetan, this Delta Lake, it will keep only Delta records, I mean, which are the different record, or it will keep all the records? It will store all the records.
Now, the transition logs by default means that you're talking about change. The transition log means
Yeah.
what?
So
The
let me
correct.
understand by an example. So suppose in first load, I have loaded data in suppose Postgres. I have loaded 10 lakhs of records. Okay. But in second load, I have file of 12 lakh records, but 10 lakh records are same. Only 2 lakh records are new. So only that has to be inserted, new records only.
Correct.
So will that look only 2 lakh records, or it will read all the records? I want to understand it, to optimize performance.
Correct. So when you are reading, you will all see there is three things: to read incrementally and write incrementally, right? Now, if you are reading your all those data, which is only change in your data frame, and when you are writing, you want to only write the change data. You don't want to write those same data which exist already over there, right? So separate transaction log, which you will have in the HDFS, will only contain newly inserted data, not all data which is there for you, right? So think in this way: the first time you are doing full load, right?
Okay.
And that time you have 1000 records. Second time you see the insert 10 insert, right? And you have delete, 2 delete and 3 updates, right?
Yeah.
Now your transaction log underscore 24 June, let's say, okay, 2020 will contain this 15 records only. I mean, metadata for 15 records, not
Right.
everything. Now, and also it won't contain entire data. For let's say this delete, you will have only primary keys because you don't need those data, which is anyway, if you're deleting the records, then you need to delete on primary key, right?
I do not want to delete actually. I just want to observe.
Yeah, I'm just saying that in case you have delete right now, because change data capture contains 3 kind of scenarios, right? And then you have also 3 updates, which can do it for your merge here. When you have merge, it can do update for you, right? Now, other similar problem that it can have is what schema structure change, right? And now it is possible that, let's say if you have 5 columns today, and then if you do design change at your source system level, you might have 2 columns extra, right?
Right.
So now,
So are
do
you
I
talking
want
about
to?
dynamic schema?
Yeah, that's called schema enforcement in Delta Lake, right? Means what? The question is that think in that way. You have transaction system. Now your customer is saying you that I want 2 more columns. So what you will do?
Right.
You will change your code in Spark, and then you will overwrite all the data if you have Parquet, right? At HDFS.
Right.
Now, if you overwrite everything, then what is the point of having Delta Lake, right? So you want a
Right.
technique which can add 2 columns without affecting existing data, right? Which can remove or drop the column, right? That's where the Delta Lake performs and shines, that you can do schema evaluation, add more 2 columns, change data type, right? Without affecting existing data, correct?
Yeah.
That you can also do with data frame.merge. And by the way, Delta Lake also stores some of the data called metadata, and metadata is also persisted at the transaction log level. In JSON file, they store metadata in that. If you do ls-l, you will be able to see that there are some JSON files, which is the schema structure of that.
Okay.
Now, to answer your original question that how long the data lake keeps the data in the HDFS, you can create the strategy and you can run this frequently. The method called vacuum, the vacuum can delete the data, and you can say retention hours here. You can say, oh, can you keep the data for 1,000 hours or 100 hours like that, right? It can
Got
keep
it.
for 100 hours and rest of that can be deleted. So you can save the space if you are concerned with the HDFS space, right?
Right, right.
There's no concern, then still you can go ahead with that. And if you want to delete everything, then you can say vacuum can delete everything. Now you want to say, I want intelligent system. I don't want to delete for 100 hours and I don't want to delete everything. I want to see the history first. And based on history, I'm saying only deleted operation data can be deleted, but updated, I want to keep it. Okay. If you want to do as such, then you can find the delta table or history. Now this will give you the some structured format data, and then based on that you can have own implementation, and then you can tell, oh, if this condition qualify, then only do vacuum, otherwise no. Got it?
Got it. Got it.
If you want to see the last operation in history, you can tell delta table or history and say 1. It will give you the last operation, what was happen on that, right?
Right,
Whether
right.
it was update, whether it was delete, whether it was upsert or whatsoever it is on the delta table, you will be able to describe that here.
Yeah. And so Chetan, I mean, Spark doesn't provide so we can achieve that much by this delta rake, right?
Can you please repeat your question, because I was
my question was that Spark doesn't provide merge support, right? Like we write merge in SQL, so Spark does not support that. So if we want merge operation, then we can achieve that using delta lake only. We do not have other option, right, in Spark.
See, there's two library called Spark, doesn't have those methods, but this all methods runs natively on Spark itself. Means the delta.io uses Spark only, nothing else.
Right.
Kind of one framework which has custom implementation and gives you high level API as a Spark user and perform that, right? If the authors of delta.io or contributors or those people, including me, when it writes that, we still need to write the same implementation, what it does internally, right? So if you need to understand how it works, if you see git command, right? Git create the hash of that everything for each transaction. And when you say git diff, it gives you the difference between two things, right? The commit has same technology and same methodology is applied in Delta Lake to define that.
Got it. Yeah. Thank you, Chetan. You're welcome. Please carry on. Yeah.
So now we'll brief on other framework called Hudi and how that also works, right? Let me come up with some source code for that. Yep. So think there is some constraint when you work with even what we were discussing so far, Delta Lake. one constraint is that it can support Spark 2.4 plus version. Means if you are legacy working on on-prem, you would not be able to go ahead with existing version because the data frame.overwrite is not supporting with Scala 2.12, and this supports with Scala 2.12. You can't work with Scala 2.11, right? So that's limitation. Now, let's say you have a use case with your customer where you can't do much infrastructure change, right? What you can do that you can have to have, because you understand this still with this logic that how this works, and you can build your custom implementation with Apache Hudi. Apache Hudi is by Uber. If you can see my screen now, this is kind of custom implementation, right? Let me save this with right. So for Hudi, you can just have a library to be downloaded, Hudi Spark bundle.jar. I'll say the link from where you can get this, but in nutshell, you need to write more code to do that. So when you get data, what you do that if you know from the source system that these are the data got inserted, deleted from, updated from the CDC like Attunity, when you write back to your Parquet, you will add one more column and say operation called insert I, update means you, and D means delete, right? And then you will do that. So for that, you need to have to define input data path, which is again, let's say in this case, I have S3 bucket, and Hudi table name, I have Hudi COW, and then Hudi table path, I have Hudi table path, which I'm creating S3 bucket. This is just path like Parquet directory. And then you have to create the Hudi option mapping. That's called map string of string, and then you provide that recorded key field operation key is primary key, so you want to record the operations on primary key, and partition field operation key is created date. So that this earlier example that I explained you with SQL Server, that how schema has been created, right? And you have table name, the Hudi table name, which is just created here, table name and string, and then you perform insert operation that you want to have operation key, and then pre-combined field operation key updated at. If updates, then you want to enable that synchronization, and this uses the Hive tables for storing the transactions. Hive table operation key is Hudi table here. You want to have partition extractor class, you provide this class name called multi-part key value extractor from Hive and Hudi. Now at the temporary data frame, you have spark.read.format Parquet, you load input data path, and then you create full data frame, temporary.with operation. You would say op is a column name newly and provide the literal call I, means this is newly insert. And you do full data frame.write to Hudi and overwrite, and you provide the Hudi path here, right? Now, if you want to have update, what you will do that you will go to the this path, and then you will provide the options called Hudi option, and again you need to provide option, or you can combine both. You provide data source write operation opt key, data source write operation, upsert operation optimal value, and say append, and the Hudi. So this will does the same thing which I told you. Internally, it creates the different subdirectory and store the insert update delete file. And when you write, it picks from the transaction logs, and this is highly compressed comparatively what natively you do, and then only move that compressed data file to the original file. This does similar thing, but performance wise this sucks compared to delta.io, right? And also provides you highly bigger maintenance to use the Hive and to use the different mapping structure that you can see here. Now Hive can also provide you the last synchronized time, and based on last synchronization time, it can pull the new data from the compressed subdirectory in Parquet, and then it performs this structure. So any question on this? this part of the hoodie, then I can just proceed for the other example of hoodie. Okay. So when you have this in Hive tables, if you see source schema in Hive, how it looks and what CERD it is using by default in that. Let me save that from my system. If I have somewhere, should have some. Yep. So so this is the example that, when you have this hoodie created, when you say so create table hoodie, table name, say MOR, this will give you the hoodie commit time, hoodie commit sequence, record key, partition path, and file path, and then all the column structure. So you have extra 5 columns to maintain that what timestamp you get, right? It's very important timestamp column in any other CDC and transaction log system, and it's partitioned by created at. So every time you create new, at that time every day you have partition of that. So then you need to only move that part, when you talk about partition, when you have a create date, create at. So every time you get newly ingested records, that remains in one partition, and only you need to shift is one partition because you have Hive system here, and that's based on timestamp there. And then you have Parquet Hive CERD here. Last commit time sync you get here, you get last real time change. This is how it looks in Hive when you create this in Parquet format with hoodie. Gives you long timestamp here. You can convert long to Unix timestamp anytime, right? You can also add in different way, which is the here you have the sequence number, time, key, path, file name, right? The only difference is that the format that you have called Parquet Hive format, and the input format here, you see the hoodie Parquet input format. But if you go with here, you have real-time hoodie Parquet real-time input format. So if you want to sync this with any streaming system, you have to change the input format for the hoodie. And that also, after you change this, you have to see that it will add hoodie commit time, it will add updated add time, it will have the record key and sequence number. And sequence numbers are operation 1, 2, 3, 4, right? And if you see OP, and these are here OP is insert, 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 right? So then you can also query this table and say, give me all data which is inserted, and filter where clause operation is equal to I, operation is equal to update U, right? So you can create something like that, unless you, and then you know that the custom configuration, which gives you the only chain data at HDFS level. So any questions so far? I think I'm done with what I wanted to present today. You can reach out to me on email, or there's one question. No. Hi, Suresh. Yeah. Thanks for that.